Okay, welcome back, everybody. Today we'll be talking about interaction. That's an exciting lecture because there's lots of cool videos and lots of cool interactive demos. But I also want to take some time today to talk about the project and about some organizational stuff. So first, I wanted to announce that IEEE Viz is happening October 25 to 30. IEEE Viz is the conference for data visualization. That is like where most of our group's lab usually is published. We always attend, and it was supposed to be hosted at the University of Utah or by the University of Utah in Salt Lake City, but unfortunately due to COVID, of course, it has to be held virtually, which is kind of like a shame. But at the same time, it gives you guys a unique opportunity because there is now free registration. Usually IEEE Viz is like $500 or so to attend, but you can now register for free and participate virtually if you register before October 9. And I would like you all to register and to attend at least 2 sessions because we will not be having a scheduled class time during that week. Because all of our, like the whole staff and myself will all conference at the virtual conference. And so just make sure to register before October 9th. We will give you also some recommendations on which lectures or which sessions to attend. There might be some highlights, some panel discussions that are like especially interesting. So definitely check it out, definitely attend it. And if you want to use this for one of your activities, you can also give us like a short 1-paragraph summary of the session that you attended and submit this as one of your activities. So please make sure that you attend and do register before October 9th. Any questions about this?
Can we submit for 2 activities?
If you do 2 distinct sessions, sure. Okay, so I'll remind you of this again, but now the other reminder that I wanted to start talking a little bit about is your project. So it's like the first day of October, and it's time to start thinking about your project. The most important thing due in October is your project proposal, which is due on October 26th. But you need to already know essentially roughly what you're planning to do and who you will be working with by October 19th. Because then we want you to announce your projects and your team in the Google form that is linked from the website. Sorry, I'm having echo. Can everybody please make sure they're muted? Or I can actually mute everyone. Okay. What you need soon is a team. If you don't have like anybody that you want to work with, use the looking for team member channel. Then you need an idea, like what is it that you want to visualize and the data set that you can actually get. And so more info is on the website here on the course website. So you can see like there's a detailed description on everything. Like what your project team is supposed to be like, your project steps. There's the schedule with the different due dates. Here is the Google form link to where you need to where you announce your project team, and then it describes exactly what is the proposal contain. It has some basic info, background and motivation, objectives, data, how you process the data, your visualization design, alternative prototype designs, must-have features, optional features, and the schedule. So this is just like a document. And then we have these 2 other things, like the milestone. This is where you already have like some of your visualizations working. And this is of course also great. Like all of these 2 parts here are graded. like the proposal, the project milestone, and the final project submissions are graded. The announcement is not graded. So that's just like administrative formality. And for your final project submission, you also need to like write up a process book. And here's details about the process book. Like submit your code, make your code actually run a live website, for example, using GitHub Pages. And you'll have to produce a 2-minute video with narration. And there will be a peer assessment component. So you will kind of be rating your teammates and how well they contributed. And in extreme cases, that can influence your grades. Okay. So yeah, I roughly went through this already, but the stages here are announcement, proposal, which is 5% of your overall grade. So that's kind of important. There's the project milestone, which is 10% of your overall grade. So that's as much as a single exam. And then the final project, which is 25%, which is like more than twice as much than a single exam and more than both exams combined. So this is really important for your grade. So the requirements for a project is that you should kind of like talk to your TA or to me about the scope. We kind of recommend that you're ambitious in your proposal. Define your goals and then categorize them, right? Like, here's what I would love to do if I can actually finish that. And we're not going to hold you to that, right? We're going to like hold you to kind of like having achieved something reasonable, but you can still have been more ambitious and had better plans. And if you just didn't meet these super ambitious plans, you can still get a perfect grade on it, of course. Check out the Hall of Fame on the website to get a sense of what great projects are. The minimum you have to have is some original idea of a dataset visualization combo. So like you can't just reproduce something that somebody has done exactly like they've done it before. It has to be interactive, and it needs to use at least 2 coordinated views. So we want to see 2 different visualizations that interact in some way. There are exceptions to that if you do something super sophisticated in a single visualization. But for most cases, we would expect that we see 2 coordinated views. So here's a couple of do's and don'ts that experience kind of has told us that like are important to follow. So we do recommend that you build a custom visualization. So just don't just do like a scatter plot and a map. That's not usually a great project, right? Think about how you can represent your data in some interesting way. You should also think about, and we strongly encourage you to do a newspaper style visualization. So add narration and storytelling to your visualization. So you kind of like want to build your visualization with kind of like the TAs and myself as your readers in mind. You should not build a generic exploration tool. So like, don't say, hey, I can upload any CSV dataset to my visualization and then you can visualize it. You should focus on one particular data set and on this newspaper style visualization. So it's like you shouldn't build, like, there's many reasons why we would like you not to do that. But it basically increases complexity. It makes this it makes it much harder to tell a nice story and so on. And so we really want you to do like a newspaper style visualization. And then the last do is make sure that you communicate your project well. On the website, like have kind of an instruction or have some kind of narration in writing, but especially also in your video, right? Like make sure that you leave enough time to create a nice looking video because these videos are, of course, important for us to get a first impression about your project. And it's also a great skill, right? Like learning how to communicate a project. Any questions so far, or any questions about the projects before I move on to something else?
Can we have some samples of projects that done previous years?
Yeah, there's the Hall of Fame on the website has plenty of links to previous projects.
Thank you.
Okay, great. So next week, we'll have a Tuesday lecture on advanced JavaScript and D3 given by Devin. On Thursday, I will talk about views, focus, and context. And I'll also talk about the exam. So kind of like what to expect for the exam and how it will work, the modalities. Just like as a brief teaser, it's going to be like a 24 hours take home open book exam, mostly focusing on kind of like non-factual knowledge, but more of like redesigning and critiquing, because that's something that works well in kind of like this, like not in the classroom exam setting. Okay, and then homework 5, we will be releasing that at the latest tomorrow. I hope it's not traumatizing anybody, but it's going to be about election polling and the probability of the two candidates winning the different states. And like this is all based on a 538 data set based on their model output. And so we'll be visualizing their model in a tabular visualization, as you can see it here. So I think that is kind of pretty topical. It's going to be interactive. So like I'm showing you just a picture here, but you can sort any of those columns. And then for each of these states, you can reveal the polls that constitutes, like that essentially make up the predicted margin of victory. Okay. So with that, I'll just get started talking about interaction. So the spectrum for visualizations is that we have, like on the one hand, we have static content. So things like infographics and books. And on the other hand, we have dynamic content. And dynamic content is like we can further distinguish, is it animated content like autoplay, maybe even a video where the user is not in control of what is happening next? Or is it interactive content where changes are a result of user actions? So the simple examples for interactive content are like tooltips or brushes or filters or anything like that. And so this is really what interaction is about, the interactive content piece. And so why do we want to interact visualizations? One big reason is that we can use interaction to explore data that is big and complex. There's too much data sometimes to visualize in a single static chart, and there are too many ways to show it. Like I've shown this a couple of times, this New York Times visualization here, but I just think this kind of like really brings home the point. The simple piece of interaction here allows you to change your perspective on the visualization, like on what is actually being shown dramatically, right? And so we'll be actually doing something like this for homework, for the final homework for homework 6. But this is just a good example of like, there's different questions that you can answer by just slightly changing it dynamically by showing these two different pictures of the visualizations. And then there's also the point that interaction amplifies cognition. So we tend to understand things better if we can touch them and if we can observe cause and effect. So here's like a nice example of an explanation of principal component analysis. And so I'll be showing this this picture again when we talk about these kind of like aggregation methods. But like here's an original data set in X and in Y, and then here's the principal component, the principal components, the first and the second principal components of this data set. And I can actually manipulate the input data here and see how it changes my principal components. And so that's just like very, like, it kind of makes your understanding of PCA intuitive, and like being able to interact like that is something that just like allows you to explore cause and effect and makes it more like more tangible, more understandable, but also probably more memorable. There's lots of ways to interact with tools. What you really have to think about is, what do you design for? Is it like a mouse and the keyboard kind of setup? Is it touch interaction, or is it a mobile phone? Or do you design for gestures, or even maybe eye movement? Maybe you want to develop an interface that that kind of like tracks eye movement and do some interaction based on that, or it could even be speech. And so these are all cool opportunities, but I do want to caution a little bit about some of them. And I want to show this brief video that discusses like the Minority Report style interactions that Tom Cruise does in that movie.
Hi, I'm Alex Kaufman. I'm an interaction researcher, which means that I explore and prototype future uses of technology as a way of understanding the future. And I really, really hate Tom Cruise. I specifically hate Minority Report Tom Cruise with his perfect haircut and his power stance, chopping at the air to sort of scroll through scenes of crimes that haven't happened yet, because it has conditioned us to expect that the future of gesture interfaces is going to look dramatic. You know, all the gesture tech we're building, the leaps, the connects, the Mayos, they all demand these highly visible gestures that are distracting us from a more pedestrian, less cinematic future that is definitely more usable than this. I mean, every time I see this scene, I think, Tom, you're standing 2 feet away from the screen. Why don't you touch it? He's replaced direct manipulation, which our hands are really good at, with this kind of elaborate sign language, which our hands are really bad at. It's as if I said, like, it's the difference between solving a Rubik's Cube and explaining to somebody how to solve it by pointing. And the thing is, our hands are very coordinated. I mean, you can be walking down the street and pick up a penny without breaking your stride. But unless you're a mime or a dancer, you're gonna have a really hard time pointing at the same spot in space twice in a row. Anybody who's ever used a Wiimote knows it's really hard to point precisely. But I think there's a feeling among people that somehow getting rid of the controller makes an interaction feel more natural. And people become so obsessed with this idea of getting rid of the mouse and replacing it with gestures that they've actually forgotten how we use our hands. Because most of the time we're not gesturing. In fact, 90% of gestures occur when we're speaking. And studies have shown that all of those gestures, almost to the last one, are for the benefit of the speaker. They help the speaker keep track of what he is saying. They convey no useful information to the audience. Now, I'm not saying that we can't use gestures and interfaces. What I'm saying is that we've got to pay attention to what their unique characteristics are. They're fast, they're silent. They can be performed at sort of any variety of distances. And most importantly, they have this kind of inherent directionality. So at least in theory, you could use gestures as this kind of meta unifying input across a series of devices. And what I mean by this is, for instance, if I point at my stereo and it turns on, and then I point at it and it turns off, and then I point at my TV and it turns on, and I point at my TV and it turns off, I've actually established a common language that both of these devices understand. And I can use this language as a way to connect them in a way, in a very intuitive way.
Okay, so that was the main point that I want to make, that these complicated, essentially interfaces that use things like gestures or even eye movement, they tend to be like more restrictive than we imagine it, as they first are. And so we'll be mostly talking here about mouse, keyboard, and maybe a little bit of touch interaction today. The one other point that I wanted to briefly make is, like, we've all seen demos of smartphones like this here. This is the Google Pixel 4 that supposedly could kind of navigate using just hand gestures. Like, you can skip a song with hand gestures. And that's kind of like a neat idea, but in practice, it didn't really get any traction. And now the Pixel 5 was introduced last week or this week, and it doesn't have that feature anymore, right? So it seems like this isn't all that important after all, even though it is kind of a cool tech demo. So one term that you'll hear me use a lot is direct manipulation. And what do I mean by that? This is like, direct manipulation is when you can interact directly with an object and get continuous feedback and updates. So here is an example of direct manipulation. Like, I have this scatterplot matrix, and I can draw a rectangle. And this rectangle is now my brush. And as I move it around, I manipulate my brush, and I can resize my brush. And you immediately see the effect that my interaction has. So this is as direct as it gets. And as opposed to, I could have a slider up here, right? And I could say, here is my my filter for the X direction, and here's my filter for the Y direction. Or I could have sliders on the right-hand side over here, where I could change like X and Y for dimensions, whatever. This is the, I'm sure the iris data set for any kind of sepal length or whatever. And so direct manipulation tends to be something that is easier to achieve and easier to understand. And so it's usually the preferred method to manipulate data visualizations. And then we can also classify types of interaction into, are they single view interactions or are they multiple view interaction? So single view interactions are things like changing over time using sliders, navigating, for example, in Google Maps, semantic zooming, filtering and querying, focus and context. And if these terms don't mean anything, this is what the lecture today is about. And multiple views is when I have interactions that affect multiple visualizations or multiple views at the same time. So for example, if I have like a selection and then show details on demand, or if I have linking and brushing, or like linking in one view, as we just saw in the scatterplot matrix, and then highlighting all of the related elements in other views, or adapting representations. And we'll talk a little bit about some of those concepts today, but most of it will be in a future lecture on multiple views. So all of you have, I'm sure, read this paper about interactive dynamics for visual analysis. And I think this is just like a really nice overview. Anybody want to give like a brief 1-minute summary of what happened in the paper? Okay, if not, I'll just do like a very brief introduction. So here, this is kind of like the main point of this paper is that there's different types of interactions. And these top 3 pins, you can see that here in the table, are the data and view specifications. So like, what data do I actually want to show? How do I want to show it? Like filtering it out, filtering data out, or sorting items to expose patterns. So for example, in the upcoming homework, we will be using sorting to reveal, for example, the states where we have the biggest, where there's the biggest gap in terms of like polling for between the 2 presidential candidates. Then view manipulation is about selecting items to highlighting, or navigating, or coordinating views for linked multidimensional exploration, or organizing multiple windows and workspaces, like moving windows around. And then the final one is a little bit more abstract. This is about process and provenance, like recording analysis histories, annotating patterns to document findings, sharing views and annotations, and then guide users through analysis tasks or stories. And so if you haven't yet, I definitely encourage you to read that paper, and just remember that there might be like a question on that paper for grad students on the exam as well. Okay, so let's go through those different animations, these different types of interactions. And let's start with a simple one, change over time and transitions. So like if you want to show a change over time, we can, for example, use a slider to see data at different times. So here is actually, this is a class project from a couple of years ago. And this is about this is kind of also nicely narrated. This is about how the US grew and how that also coincided with railroad development. And so you always have like a nice story about like what is in which year. In the year 1800, the United States consisted of these states. But then if you continue over time, you can see how the United States changed. And always like, again, an updated story. And then you have a visualization of the size on the right. And then these lines here show the railroads and how the railroads have connected the country. And then finally in 1900, where the United States is very similar to what we know now. Not completely, but very similar. So very simple interaction. You just change something with a slider. And you switched, you jump to that year. And so notice, like, remember when we talked about these fertility rates example, where we had this this animation of how the fertility rate of the US and Japan changed over time, that this wasn't necessarily the best idea to visualize it like that. So sometimes it's better to show the difference explicitly instead of like letting people actually change time with a slider. And so we also use a lot of transitions in visualizations. And why do we care about transitions? Well, as I mentioned before, like different representations support different tasks. For example, a bar chart supports something different than a stacked bar chart. But sometimes we want to switch between those different states, and transitions make it possible for users to track what is going on. And I want to show two examples here that have some nice transitions. So this is kind of like a tool that visualizes single nucleotide polymorphisms. It's not all that relevant here or important what's actually going on in the visualization, but just think of this data that has like a couple of different dimensions that are not easily shown here. So we can switch between this 2D view to like a view with even spacing to a view that is completely different. But notice how nice these transitions are. Here we have like a quantitative view. Then we can switch this back into 3D, or we can switch this back first into the original representation and then move it into 3D and encode something else here on this dimension. And then you could add like another like piece of information in 3D, or you could then transition it over into like a top view to show this different data dimension recombination rates here from above. I don't really like criticize or like 3D. The use of 3D here is well, not terrible, but the point of this is about these nice transitions that you have to understand what is going on, what is changing between the different views. And then the second example here, and this is something that is like in tabular visualization, it is very, very often useful to sort. So if you like here, this is a tabular set visualization, and we can simply sort by any of these attributes that we care about dynamically, and then reveal, and through these transitions, we can kind of have a sense of what is going on. So if we, for example, like we see that like the biggest intersection here with this big bar has now gone green. And so we have a much better mental model of what is happening if we have these transitions. If ideally you want to have like animated transition with smooth interpolations between states or visualization techniques. And for like something like sorting, that is kind of easy to do, but sometimes you have to be a little bit more creative. So here is an example where that does these animated transitions between stacked bars and grouped bars. So this is a little fast maybe, but you're supposed to be able to control this here manually, and then it does make a ton more sense. And so people have done research, of course, on are these useful? And so here is like a brief video that I want to show about these animated transitions and whether they're like a good idea and in which context they're a good idea.
Analyzing or presenting information using statistical data graphics, it is common to look at a number of related graphs. For example, the viewer of a bar chart may want to switch to a pie chart to view relative percentages, transition to a scatter plot to look for correlations between two variables, or drill down by breaking up the data by categories. Animation is one promising approach for facilitating perception of changes when transitioning between data graphics. Using design guidelines motivated by research of human perception, we have developed Dynaviz, a system supporting animated transitions for statistical data graphics. Dynaviz provides animations for a number of different transition types, including changes of perspective, filtering operations, and viewing changes of data over time. In some cases, changes of value require changing the axis scales. Here we show a sorting operation. Animating everything at once can result in items occluding each other. By slightly staggering the movement of each of the bars, Dynaviz makes the sort easier to follow. Here, a bar chart becomes a radial donut chart, By growing the wedges to take up the whole circle, we form a pie chart. We can also perform drill down operations, breaking up the data further into distinct categories. We can then unstack the bars to view the same data as a grouped bar chart. Of course, we can always reverse the transitions to return to the view we started with. We might want to compare different variables in a scatter plot to look for correlations. Here, we keep the y-axis values as the same as the bar chart, but use the x-axis to show a new variable. Animation is also helpful for showing transformations to the data. Here we show applying a base 10 log transform to the data. Both data and axes smoothly animate to show the results of the transform. Visual encoding such as shape, color, and size can be used to visualize additional data dimensions. To evaluate the use of animation in data graphics, we ran 2 controlled experiments. The first experiment asked users to follow 2 targets across an animated transition and click their final positions. To better test how animation affects memory, we masked the display after the transition by turning it black. We compared static transitions, direct transitions in which all items animate at once, and staged animations where movements were split up over time. Our results found significant benefits for animation and found that staged animations, which split up movements through staggering or separate stages, consistently improved accuracy.
Okay, so what they're saying here is that animations support, are easier to follow, support kind of like understanding what is happening between 2 different transitions. Can anybody think of like a limitation of that? So what do you think if I have a table with 2,000 elements exactly, when there's too many data points? That's exactly right? Animations are useful as long as you can still make sense of what is going on in an animation. But if there's just too much movement, then it usually doesn't pay off. And coincidentally, it also becomes a bit of a performance problem. So if you have like a ton of data points, it is usually not the best idea to use animated transitions. And so instead, it might make sense to just do a hard switch. So changes can be hard to track. And also remember that you have the option of also showing the 2 views side by side. You don't have to animate your pie chart and a bar chart. You can also show both at the same time, and you can show linking between them. You can link between them so that you see individual elements where they are in both of these charts. So the other big point about animation or about interaction is, of course, navigation. And so we all know navigation from tools like Google Maps. So in Google Maps, if I look for the University of Utah in this globe, I can kind of see where it is in the context of everything else. We can zoom in, and so we can pan, move the field of view around, and we can zoom out. And so Google Maps also has this nice feature that I'll talk about later. It's called semantic zooming. So notice how I'm zoomed out. It has kind of state borders here. If I'm zooming out further, the state labels disappear. But if I zoom in more and more, then we get additional information depending on the layer that I'm at. And so we are kind of now we have switched to different images, but now street grids appear, and so on. And so this is called this gives a kind of semantic zooming. And this doesn't only work for maps, but you can also do this for 3D scans or other 3D objects, or even 2D objects. Here we have an MRI scan of a child's brain with some kind of pathways traced here. And I can navigate around here, and I can also navigate here in 2D with this visualization. So this is just another example of zooming and panning. And one interaction that has become increasingly popular is scrollytelling. Scrollytelling is essentially telling an interactive story and making having the interaction happening, but just scrolling through a page, which is kind of nice, but things that you need to consider is your scrolling continuous, or do you have discrete state? How do you enable direct access to the various states? and is it kind of like expected or unexpected? And I kind of like refer to this blog post here by Robert Kursara, who runs Eager-Eyes, this visualization blog, where he has a very strong opinion on scrollytelling. And so I'll show you a couple of examples here. So here is a New York Times piece by how the US and the OPEC drive oil prices. And I scroll, and as I scroll, like here I have oil supply versus prices. And then we get more information. Essentially, by scrolling, I don't move my canvas anymore, but I've broken up essentially the yearly data into monthly data. Now axes are changing. And then if I keep scrolling, and it shows like a focus, a pull out here about like this particular like time frame of more recent like oil production. And so we keep going, and like basically we're making these massive transitions as we are scrolling, but we're actually not moving to any specific, like to a new place. So what do people think about this this kind of interaction here?
Personally, whenever I have the page like that, I feel sometimes also exhausted if I have to go all the way to the end to get the full story. It's kind of hard to get a big picture easily by having to go all to these pages and transitions.
Exactly, it's really hard to get the big picture. You don't know where the end is. It's kind of like hard to navigate. One kind of like thing that they have here is they still have like this stepper interface where you can jump to discrete states, which I think is a nice add-on. So you should definitely do that if you want to use a scrollytelling interface. But I think this is a little, let's say, scrolling is maybe a little abused here. So let me go show another example here. This is the what's warming the world one. So here, this is like about climate change. And so here's the observed temperature. And now, like as we scroll, we see like different hypotheses what could be changing the world. So I keep scrolling and so on, and the point that they want to make is, of course, that it's not any of the things like volcanic activity or orbital changes to the Earth and so on. They don't really explain it. It's also not deforestation or ozone or aerosols and so on. And then if you look at greenhouse gases, it matches nicely. Again, similar to before, we are scrolling. I'm scrolling here with my mouse, but it's not actually scrolling the page. It's kind of hijacking this interaction. And so I would say there are similar arguments on pros and cons. Why do you think scrollytelling has become so popular?
It looks fancy.
Looks fancy, that's certainly true. It's pretty cool. You have nice animations.
Mobile use.
Exactly. I think that is a key point, right? Like scrolling is really easy on mobile. I can simply like swipe up, and keep seeing it. And so you notice that a lot if you look at like the history of news-based visualizations, that in the last, let's say, 5 years or maybe even more, things have moved all to like mobile, because I think that pages like the New York Times or Bloomberg or Washington Post, they get like a substantial amount of the traffic on mobile. And so they really think about mobile, like how they can enable mobile, maybe sometimes to the detriment of showing something more interesting on a desktop computer. And scrollytelling is certainly one of them. Like if you have to click little stepper buttons, that might be much harder on a mobile phone than just keep scrolling. Okay, so moving on to semantic zooming. And I mentioned this already when I was talking about the Google Maps, that as I'm zooming in, more information appears semantically. Now, if like semantic zooming works not only for maps, but it works for abstract things. So here, a while ago, Windows introduced semantic zooming for their kind of like navigational concept. It's not in Windows anymore, but I still think the video here is useful.
Hello, my name is Adam Barlow. I'm a program manager on the Windows Developer Experience team. Today, I would like to introduce you to the semantic zoom control, which is included as part of the Windows library for JavaScript. Semantic Zoom is a control used by apps in Windows 8 for displaying large sets of content in a truly user-friendly format. Semantic Zoom is unique in that it provides an easy-to-navigate, touch-optimized view of the data you present to users. In designing Windows 8, we wanted to ensure users wouldn't have to pan tediously through large sets of content with touch. Semantic Zoom is our solution to this problem. It gives users the capability of quickly jumping to sections of the view and greatly reduces some of the pain points traditionally associated with large collections. As you can see here, Semantic Zoom allows the user to quickly jump to any given location in the view, in this case, the last group of my start screen. Not only is Semantic Zoom a great navigation mechanism, but it also allows you to communicate a higher level organization to your data using the zoomed out or semantic view. For example, in the People app, you can zoom out. Here you will see a higher level abstraction of the data in terms of letters of the alphabet. This is extremely powerful and can be used to communicate important information to the users of your application. For instance, you could use the cell spanning functionality of the WinJS list view to demonstrate the relative sizes of your groups. Although Semantic Zoom is easily performed with touch using the pinch and stretch gestures, it also works well with mouse and keyboard, ensuring that regardless of input mechanism, your users will have access to the important benefits of both the jumping and presentation functionality. With mouse, you can use the Semantic Zoom button.
Okay, so here's another example that is like a kind of like a systems monitoring application that uses Semantic Zoom.
LiveRack, interactive visual exploration of system management time series data. We show LiveRack, a visualization system for viewing large quantities of time series data in the domain of system management. Monitored devices are represented by rows. This label shows aggregate information about a group, NFS, with 4 devices. Columns show one or many parameters collected from the devices. This column shows CPU usage. In the current overview, each cell is a small colored block. In these 4 cells, green means CPU utilization is above 35%. As I make the cells larger, labels for the individual devices become visible. Also, when the cells get big enough, the server is queried for more data, and then the representation changes from blocks to sparklines. Making a cell even bigger results in semantic zooming to show a more detailed line graph. We can see the current time range by looking at the time boxes to the bottom left and bottom right of the data area. The blue lines show.
Okay, I think you get the idea. So as you zoom in, you can like bring in more information or things like axes and scales, if it's as is possible, on that item of interest that people are zooming in. So that's really the idea behind semantic zooming, and that's a very powerful technique. Related to semantic zooming is this technique that's called focus and context. And focus and context is about carefully picking what to show, like that's your focus, and showing that in detail, and then hinting at what you're not showing. That's kind of the context here. And so there's many different ways to achieve that, but it's really about the synthesis of like visual encoding and interaction, where the user selects a region of interest to focus through navigation of selection, and then you provide context through aggregation, reduction, or layering. And so, like, if you like, this is how this is classified in our textbook by Tamara Munzner. There's these different ways of providing focus context through elision, superimposition, or distortion. And so, elision is when you show the focus item in detail, but other items are summarized for context. So like the classical example of this are these kinds of trees that you can navigate. So here, this is the space tree. If you click on a node, you kind of reveal this, the hierarchy that is hidden behind it. And if you go to a higher node, and the rest of it collapses. And so you have a bit of a sense of what is going on in the tree, what is roughly the structure of the tree, but you can kind of like focus on the nodes that you care about, for example, through like a search or through explicit navigation. Kind of a more advanced concept of this is what's called degree of interest functions. So this is degree of interest are based on the observations that humans often represent their own neighborhood. Like if you think about anything like your neighborhood, you know exactly what's going on in your neighborhood. But you might have only like a rough mental model of landmarks that are far away. And so for visualization, the goal here is to balance between some local detail and some global context using this function here, where you have like your degree of interest of an element, and an element could be anything here. Let's suppose it's a node in a graph. So like you're calculating the degree of interest of a node by using this a priori interest function. So for example, if I have highly connected nodes in my graph, they might have a high a priori interest. Or if I have very big cities, they might have a high a priori interest. And then I have a distance function. Like I'm currently looking at one particular node, and then everything that is in the proximity of that node is more important to me than something far away. And so the degree of interest is a combination of this like a priori interest of an element and the distance to your current focus. And of course, you could also have multiple foci. And so this has been implemented. This is a very generic idea. It has been implemented mostly in the context of essentially geometric scaling and distortion. And so, well, one example here is this DOI tree, which is like an interactive tree with animated transitions that fit within the bounded region of space. And the layout depends on the user's estimated DOI. So here's a short video of that. So the tree here is being navigated, and the elements are kind of like estimated what is relevant based on this a priori interest and your distance in the tree. You can then use something like logical filtering based on degrees of interest. You can use geometric distortion of node size based on degree of interest. You can use semantic zooming together with these degree of interest functions so that you can reveal more content on a node that has a high degree of interest, and you can aggregate representations of any of the subtrees. You can also do degree of interest without a distance function, as the distance function can lead to fairly big involuntary changes. So you can simply say, hey, here's my kind of like, here's my a priori interest, and this is kind of like, I can then explicitly navigate that space, but I don't really account for distance functions. And so I linked the video here of one of our projects, but I don't want to show that now in the interest of time. So if you're interested, just take a look at this afterwards. Superimposition is a different technique for achieving focus and context. Here, the focus layer is limited to a local region of view, and instead of stretching across the entire view. And so what do I mean by that? It's like here, like magic lens is like a classical example, and this is like an old video, but it's kind of like interesting to see that idea.
Tool glass sheets can include magic lenses, visual filters that modify the appearance of the objects beneath them. For example, this lens magnifies the objects underneath. We control the magnification with this slider, increasing or decreasing. This second lens is a filter that shows only red objects. Overlapping the two filters composes their effects. When we place the magnifier lens over the red object lens, we see that this little red object is a Time magazine. Magic lenses can be used to modify a scene's appearance in small regions while leaving the rest of the scene alone as context. To move the Time magazine from the kitchen table to the nightstand in the bedroom, we can use two different magnifying lenses, one over the dining room table and a second over the nightstand. We then simply select the magazine and drag it from one place to the other.
So here's another demo of that. That is kind of like a combination of the magic lens and the tangible interface, which is kind of a cool idea here.
Up to now, tabletop interactions are limited to the two-dimensional surface. In this example, users can zoom and pan through large pictures by performing multi-touch gestures on the table surface. In the following, we show how this task can be accomplished in a more natural way. For this purpose, we developed a paper-based mobile display that users can freely move through the physical space above the tabletop. This magic lens works as a magnifying glass to zoom in on an image by simply lifting or lowering the lens. At the same time, moving the display horizontally results in a panning operation. In order to help users maintaining the context, a circular contour line is projected onto the table display. The technical setup of our system is simple. The images on the lens display are generated by a projector and an infrared camera above the table. It works because the mobile lens contains markers in the corners that reflect infrared light. So the infrared camera above.
So I want to skip over the technical details, but here is an example that is not just magnification, but provides different context.
Of a contextual model. In our example, medical students can study different systems of the human body. By lifting or lowering the lens, they can choose between the skeletal, muscular, blood, and nervous systems. At the same time,
okay.
layer can be explored.
So to recap, magic lenses are essentially allow you to modify a scene, and the lens can be just a magnification, but it can also show you something contextually different. For example, in this case, depending on the layer that you're interacting with, a different kind of like functional system of the body, or in the other case, like a filter for objects that are red. You could also use a magic lens to label. So for example, I could have a labeling lens if I have a dense scatter plot. I could have like a lens like the circle here, and then I would show labels for all of the elements that are currently being like within the area of that lens. Okay, so the other like big focus and context technique historically is distortion. So here, like you use geometric distortion of the contextual regions to make more room for the details in the focus region. And so that's kind of inspired by like actual physical lenses. And so here's an example for like a streamlined data. I can actually give a live demo here. So like the point I wanted to focus on here is this visualization here. I have my time slider. These are movie genres, like music genres, and their popularity over time and how they evolved. And you can see that essentially I have only high-level categories like rock music outside of my focus area. And here time is kind of like broken up non-linearly. So you have like 1980, 1978, and so on. But then we have like much bigger time gaps in that area here. And I can dynamically change what I consider to be like the focus area. And I can move that around. And so I could kind of like move that to my high school years here and see what are the popular movie genres during my time in high school. And so here we use distortion to kind of like show details about an area that you care about, and then kind of like show context, like the focus element here and the context element outside here, to understand what is going on globally. A different idea is kind of like, well, use the same idea, but don't use distortion. Like have focus elements here. Like this is a timeline of temperature, precipitation, wind, and weather. And here's like a live demo, but I think I can like explain this just with this picture here. So you have your focus region up here, and that focus region here shows explicitly like some, in this case, temperature information. And then the context region, like October to April for temperature, simply just shows like a histogram of the temperature. So that is kind of like a much more compact representation, because I now see only like the distribution and not individual points. And so these guys here have developed a couple of different ways of visualizing this, like very like tighter bars, histograms, or dot plots instead of timelines, and again histograms to visualize this kind of stuff. So here the difference is that this is not distortion, right? This uses focus and context by using like two different visualization techniques. One's something very detailed, and then the other one an aggregated representation. And so I think that is kind of like a very neat idea. More explicit uses of distortions are like then using 3D space. And so this is mostly of historical interest, because this is like one of the very early like information visualization paper, the perspective wall. And I want to kind of show briefly this video.
segmented wall is used to lay out 2D information onto a 3D segmented wall. The front segment is used for viewing details, and the side segments provide context. In this case, each node represents a file with its horizontal position determined by its date of last modification. Vertical position is used to indicate the class of the file. When a node is selected, the wall moves to bring the selected node to the center of the front section. As before, we have a fisheye view. We're using 3D to make better use of available screen space, and we use interactive animation to exploit the perceptual system's ability to track relationships between moving objects. In regions of the wall where there's too much detail, we can stretch the wall like a sheet of rubber to reduce clutter.
So a couple of cool ideas in here, but that never really caught on, and probably because of the problems of the 3D distortion here, right? Like the labels, I can't read any labels in there. It kind of like gets difficult to parse. So we're not now like exploring our calendar like this. And another classical, like this was like a 2D distortion, but you could do this, of course, or like a 1D distortion actually, but you can do this, of course, in 2D. So you could kind of like take something like a regular grid and have a lens object and then zoom in on these nodes here, like you see that here with that lens. And so here you have like the function of magnification. Like it's magnified around the lens, then it decreases magnification and then kind of like compresses a little bit, and then you have like your like normal layout. And so that was a very popular idea back in the 90s, and we have tools like the Hyperbolic Browser where like graphs or networks or trees are projected into hyperbolic space, and you can dynamically navigating them. Again, I'm going to skip this video in the interest of time, but take a look at it. Here's like another case, like looking at bus routes. I forget which city this is, but it's like a you can look at where the bus stops are and like locally see exactly. Here's the street corner. So let me show this video briefly because it's going to make a point I want to make.
It's possible to monitor the activity of buses throughout Singapore, but considering the large volume of information, exploring individual bus stops is a challenge for visualization. In order to achieve this, an interactive tool has been developed. It acts like a...
Okay, so if you see this, like what's your intuition? Is this going to be useful if you want to find a bus stop?
That's a lot of bus stops.
And so why is it not useful?
Doesn't really show anything that's around the bus stops. Like if you wanted a bus stop next to, say, the Trader Joe's, you couldn't find one because there's no Trader Joe's on the map or something like that.
Yeah, that's true. It misses important context. Yeah, my biggest issue here with something like this is that we have like this extreme compression around the edge of the lens, right? So I basically, like I can see this what is within the lens in detail, but I have a very hard time understanding what's going on just outside of the lens. And so this is kind of like, these methods have kind of, they make sense in some cases. For example, if you have one-day list, a one-day list, like here, for example, you can like navigate a list or a tree like that, then it might be useful. But for the 2D case, it tends to be it tends to be just like too complicated. So when we think about distortion, there are certain concerns. Like it's unsuitable for relative spatial judgment. So if you have maps, it's a problem. We have like the mental overhead of tracking the distortion. You need to be able to visually communicate your distortion through grid lines or some shading, which kind of adds visual clutter. And then it's also hard to actually acquire a target because you have the lens is displacing items away from the screen location they were at. And so when people study this empirically, it essentially it doesn't give great results compared to separate views and temporal navigation. And so nowadays, like people kind of like generally recommend don't use distortion until you have like a very compelling reason to do it. This is a little bit related, but I've just found this technique so super cool that I want to mention it here. This is transmorgification. If there's any Calvin and Hobbes fans in the audience, they will know what that means. The idea here is to straighten some complex shapes in image space. And that can be spatial data or another viz technique. And I want to show that video briefly. So what's happening here, they traced like a river by a simple touch interaction, and now they can show this river like linearized at the bottom. And then you can map that also to a circular layout. Let me jump to this example here. You can also do this with like graphs, and these are all just images. So here, this is like an icicle plot. And you could use this image transformation to make it into this radial chart. Or here you could take this rose petal chart and convert it into a pie chart. Okay. So the next technique I wanted to talk about is overview and detail. And what I mean by overview detail is if you have multiple views where one view shows the overview, the other one shows the detail. So the classical example is video games where you have kind of like a map of like where your character is in. This is like a screenshot of Warcraft 3. So you have like one detail view here, and then you have like the map of like the global world that you can use to quickly navigate between those different spaces. And this is now more or less gone from tools like Google Maps. A couple of years ago, they also had like an overview to give you context of where you are. And I think that they have removed this feature because it's now so easy to kind of like zoom out and zoom in. And it like usually people have a good sense of what is the global context of the place that they want to go to, and they care more about the individual directions. But for use cases like video games, something like that matters still a lot, of course. And then the tooltips also fall into that category. So here, this is like a historical example from like 1994 that shows a tooltip. Here, this is like a movie application. It shows like popularity versus time. And then one of the movies is The Witches of Eastwick that has been selected. And now it shows detail about it, including a picture of Michelle Pfeiffer back then. And the last topic I want to cover for today is this filtering and dynamic querying, which is also called brushing or selecting. And this is a picture of Ben Schneiderman. He's like one of the kind of like seminal figures in visualization, and he kind of like came up with this visualization information seeking mantra: overview first, zoom and filter, then details on demand. And so the previous example I had here is actually also one of his tools. That this is kind of like details on demand part, but now let's look at zoom and filter. And so here, this is this dynamic queries interface. Here we want to like define a criteria for inclusion and exclusion. And I'll briefly show that video.
And again, the principle is to visually demonstrate the query components and the results and provide rapid and immediate feedback. For that, I'll take a look at the demo here on this display. Just move over to the side here, and we see on it a map of the Washington, D.C. area with the Potomac here. And this is an improved version of where we were a year ago in terms of dynamic home finder. The scenario I present to you is that we're coming up on the new administration, and you've taken a job with the Clinton administration, and your spouse is going to be working at the University of Maryland. You're looking for a home. So the first thing to do is to mark where you want to work here at the University of Maryland, right about, let's say there, the A marker. And then your spouse is going to work downtown in the executive office building right about over there as the B marker. Okay. And now each of these points of light on the display represent a home for sale. And if I move to the right, I can control this display by choosing the distance that I want to be from point A. And now it's set at 30 miles, and I'm going to bring it down. And you can control rapidly, incrementally, and reversibly the distance that you wish to be from point A. So let's say you decide, you see there's plenty of them. So you say you want to be, let's say, 5 miles from work so that you could, let's say, bike to work. And now you want to be somewhere inside that range from B. So you slide down, and we now can see the set. And this is, looks like we've got 40 or 50 homes over there. If I now choose about the number of bedrooms, I really want 3 or 4 bedrooms. So I move this double box slider to be 3 or 4. I've still got about 30 houses on the display. So why don't we look at the price now, and we want to keep the price down, let's say about 170,000.
Okay, so we now, of course, like this is something that we know well from like everyday interfaces nowadays. And so, for example, if I were to look on Amazon for like a big screen television, I could use these kind of like faceted search interfaces here. It doesn't actually have any kind of like this continuous, like I can't look by price. I can't like brush by price, but I can do things like I want at least 50 inches or I want 50 inches to 59 inches. Or you could say, I really want to have like a 4K TV. So that's kind of like the same idea. Like I want you like now in an activity, like in a redesign exercise, I would like you to kind of like, this has been like an important paper back in the day, but it doesn't include direct manipulation, right? Like you have these sliders on the side. And now I would like you to like develop in a group to include direct manipulation here in this interface. You want to show the distribution of homes across a variable as well. So like we don't, like for example, here we don't know what will happen if we have if we change that slider, right? Because we don't know how many homes are there that have a value of 500,000. And I want you to sketch alternative interfaces to use different criteria in different areas. And so I'll start breakout rooms. We will like not be coming back today because we don't have a lot of time. And I'll discuss solutions about this next time. But you can, of course, submit this again to any of the activity boxes. So let me, I'll quickly, like Shusha, can you please put the link to the exercise in the chat while I set up the breakout rooms?
Yeah, I have put the link to announcements.
Okay, perfect. Okay, so thanks everyone. You can just like when you're done, you can just sign off. I'll keep the Zoom room open. If you have any questions about today's lecture, you just post it on Slack. But in the interest of time, I'll just open up the breakout room now. Thanks.